Okay, look at this. On this page right here, we're starting to graph the sine function. We're going to change some numbers in the equation to see how it changes the graph. All you're supposed to do right here, it talks about how it's going to change parameters. The A and the W, or omega, those are your parameters. Okay, it says record your observations below. So I'm going to simplify it now. I know you guys have already been working on it, but I'm going to do it now too. And what you're supposed to do with the graphing utility is you're supposed to put each of these numbers in one at a time as A to see what it would do to the graph. That's all you had to do, and it says that in the description. So let's write stuff. Let's start with when A is greater than 1. When A is greater than 1, that would vertically stretch the graph. Alright, the rest of it I'll simplify a little bit more. If A was between 0 and 1, meaning that it was a fraction that's less than 1, then it would vertically, yeah, you can say shrink, I like that. Shrink or compress, whatever means making smaller the graph. When A was less than 0, now that one was kind of weird, but still something vertically happens to it. That's a vertical flip. And when A equals 1, there was no change. Changes to A change the max and min. The maximum and minimum values of the graph are, I'm going to say, equal to the A. Well, at least really close to equal to the A. This would be your max. Your min would be the opposite. So it would be negative A. And the last thing, if A was 0, then your graph, then you get y equals 0. And so that's just a straight line, a horizontal line, at the x-axis, at y equals 0. Go to our next column. Now in this column we're looking at omega, and I think for this one we'll look at a graph for a little bit to see what changes on our graph. Okay, so this is the regular sine function, and what we're going to do is we're going to put a number in front of this x right here to see how it changes the regular sine function. The regular sine function is red for my graph the whole time. So I'll put sine, and then let's put a 1 in the x spot. Did that do anything to our line? No, it just changed it blue. Nothing happened different. So what if I put a 2 in there? What happened to our line? Now you want to look at the end of the first period, or the first cycle on the red line. You see where it ends? It goes woo, and it ends right there. Oh, where does this one end? Woo.
You got shorter.
Yeah, this ended at pi. It horizontally compressed, right? So if I go, let's try a bigger number. Oh wow, let's try an even bigger number. Oh, let's try an even bigger number.
So it compresses?
Yeah, so it looks like whatever number you put in there that's greater than 1, we have a compression. So I'm going to say horizontally compresses. You guys use 100 to do it? Or you could say shrinks, I suppose. Alright, well what if that number is between 0 and 1? What would happen? Let's see. Delete. Let's put 0.9 on there. I can't see anything. Let's see, 0.5. Oops, I put point. Well, that's weird. Look at the end of the cycle on the red line. Still at 2 pi. Where's the end of the cycle on the blue line? 4 pi. So let's try a smaller number than 0.5. What's a smaller number than 0.5? 0.2? Okay, that sounds good. Whoa! You can't even see the curve anymore. Here, let's back out. Look at that. For a full cycle, it ends on, it looks like 10 pi. Wow. So what happens to the curve when the number is between 0 and 1? Horizontally, I'm going to shorten it there. It stretches. Or you can say expands. I like the word stretch, so I'm going to write stretch. Horizontally stretches. What if the W was negative? That is going to hori what? Let's see. I'm going to change this back to just a 1. And then let's change it to a negative 1. What happens? It looks like it vertically flips, just like before, right? But it actually horizontally flips. You see this point right here? This max on the red line? It went over here on this blue line. You see this x-intercept right here? It went over here on this x-intercept on the blue line. So it horizontally flips. It hori flips. It's really hard to notice the difference, and I'll be honest, you probably won't see very many W's with negatives. Like most of the time, I rarely see those, because it just makes a lot of the problems a little too confusing. So I would never guess that the W is negative. When W equals 1, there's no changes. So I say no changes. Changes to W change the period. That's the ending spot. Remember how I kept comparing those? The number of cycles of the graph increases or decreases with the period. Or no, with omega. Yeah, put the W with the W. When W is 0, we get y equals 0. So that's just a horizontal line on the x-axis. Okay, when we flip the page, we have different examples so that we can describe what's going to happen. Now, we don't have to graph these to see what's going to happen. I like graphing because I like the visual, because I'm a visual learner. But we don't need it. See, look. Is that 5 an A or a W? That's an A. So that 5 is greater than 1. So what would you say is going to happen to this graph? Look at your chart. It says vertically. Vertically stretch. And that's it. That's all that's going to happen. Let's do number 4 right here. There's a negative 1/2 in front of sine. So what's that going to do? It's going to vertically, there's two things. Vertically shrink or compress. And it's going to vertically flip. Does that make sense to y'all?
Yeah.
Okay, I want to walk around. I want to see what you guys write for number 3. Go.
Wait. So
I realized something as I was walking around. Some of you guys are kind of confused with the fractions and negatives. We should probably fix this chart right here so that this says the absolute value of A. If the absolute value of A is greater than 1, then you have a vertical stretch. If the absolute value of A is between 0 and 1, then it compresses. Okay? And then that's it. We're not going to put absolute value on this a because we need to know if it's negative or if it's positive. Okay? And plus, that would never be able to happen, an absolute value being less than 0. So that means when we come to this, we should have a vertical flip. I'm going to say vert flip and a vert stretch. Okay, let's do 2 of these really fast with W's, with the omegas. Okay, for this one, we have a 5. That means it's going to hori what? Hori shrink or hori stretch? Yes, that'd be shrink or compress, same idea. And then hori, no, that's it for that one, I guess. Okay, what about that one when we have a 1/2 in front of the x? That would hori stretch. Okay, next I want to look at the graphs and see how you would be able to graph these now.